OCR and other legacy document processing solutions have been around for a long time, but they are often error-prone, costly, and really time-consuming. Hi, my name is Navneet, and I'm a senior product manager on the Amazon Textract team. Today, I'll be joined by my colleague, Martin, and we're going to talk to you about Amazon Textract, a machine learning service that can help you automate your document processing workflows. Specifically, we shall talk about the queries feature within Amazon Textract that gives you the flexibility to specify and extract information from your documents with really high accuracy. Let's dive right in. The agenda for today is fourfold. We'll first start with a quick overview of AI ML services at AWS. After that, we'll talk a bit about legacy document processing solutions and the issues customers typically face with them. We'll then talk about Amazon Textract and how its current capabilities can help you address these issues that legacy solutions face. We then deep dive into the queries feature, which, as I said, gives you real flexibility to specify and extract information from documents. And at that point, I'll hand it over to Martin, who's going to do a real life demo using the queries feature with some real life documents from mortgage and insurance industry. Okay, the AI/ML stack at AWS. At AWS, we have the broadest and the deepest set of machine learning capabilities. At the top of the stack sit our AI services, which are meant for developers with zero ML skills or close to zero ML skills to incorporate intelligence into their applications. Amazon Textract is one of these AI ML services, which helps developers incorporate the ability to extract printed text, handwriting, and documents from virtually any document into their applications. Let's take a step back and understand why document processing is actually important. The quick answer to this is that documents are a primary business tool across industries. From finance to insurance to legal to even education, documents are commonplace across these industries and are a key part of their business workflows. So now what is the issue with the current solutions out there? Well, customers typically use one of three methods to extract information from documents. The first is manual or human review of these documents. This obviously is highly labor intensive, time consuming, and very costly, and not to mention often error prone. The second method customers use to extract information from documents is OCR technology, which, as I mentioned, has been around for decades. The problem with OCR technology out there is that it works best on really simple documents. And secondly, the output is a bunch of text. And what that means is that it strips the document of any structure like tabular information or key value pairs. So if you as a customer want to extract information or infer information from OCR output, you often have to build custom post-processing to infer that information. And this is not scalable and extremely costly in many cases. The third option that customers have right now is basically to use a rule-based or a template system to extract information. This too has a few issues. Firstly, it is only as good as the base OCR technology that it is based on. And secondly, it is not really scalable. As more document versions and formats and templates are added, you have this additional cost of maintaining these templates and then taking care of them and improving them over time, which is not scalable for you. This is where Amazon Textract comes in. Like I said, Amazon Textract is a machine learning service offered by AWS that makes it easy to extract printed text, handwriting, and data from virtually any document. Amazon Textract goes beyond OCR to not only give you the text in the document, but structured elements like key value pairs and tabular information so that you can easily infer the information that is embedded in this document. And as I mentioned, you require no ML experience to get started and integrate with one of the many APIs that Amazon Textract offers. What this means is that it drastically reduces the amount of manual effort you put in to extract information from your documents. And as a result, you end up lowering the cost of your operations by using Amazon Textract. Customers across key verticals and business are actually using Amazon Textract to drive business outcomes. We have customers in financial services, public sector, healthcare and life sciences, and even manufacturing and retail who are using Amazon Textract. And it's driving three main outcomes for them. Firstly, it's really improving the productivity of their workforce, who are no longer spending time extracting data from paper documents, but instead using it to make business decisions. The second, it is really improving their end user experience. And what I mean by that is customers are now able to, let's say, process a bank loan quicker, adjudicate claims faster, and it's resulting in a much better end user experience for their customers, which is helping their business. And finally, it's resulting in improved decision making because, as I said, your workforce is no longer spending time in common tasks like extracting data, but instead trying to spend their effective working time using the data to make better decisions. Let's look at a few examples out there of customers who are actually using this. Black Knight is one of the biggest names when it comes to mortgage processing software. And they have a product called Underwriter Assist, which is an AI powered mortgage solution. Underwriter Assist leverages Amazon Textract under the hood, and it has helped really reduce their cost base and improve operational efficiency, which in turn has resulted in much higher customer satisfaction scores for Black Knight. Another example in a different industry is Anthem, which is one of the biggest processors of healthcare insurance claims in North America. Anthem chose Amazon Textract to help digitize and automate its claims processes, and they have already automated almost 80% of their claims processing workflow. And they want to go even further and push this to 90% automation levels or higher on AWS soon. It's not just Black Knight or Anthem that is already using Amazon Textract and getting the benefits of this service. This slide shows a range of customers across different industries and verticals that are already using Amazon Textract. It's not meant to be an exhaustive slide of all the customers, but just a snapshot into the variety across industries that are already automating their document processing workflows using Textract. Okay, now let's switch gears a bit and learn a bit more about what is out there with Textract and its product portfolio. So you might already be familiar with Textract's OCR or text extraction capabilities, but we go much beyond that. We provide handwriting extraction support, as well as support to extract structural elements like key value pairs, which are found in forms, as well as tabular information from different documents. Over the last year or so, we've also gotten into specialized documents and released two specialized APIs, which are trained to extract information from documents like invoices and receipts, as well as ID documents. And finally, our most recent feature launch was the Queries feature, which helps customers specify the exact information they want and extract that from a document. Over the next few slides and minutes, we'll touch on each of these features a bit, and then deep dive really on the Queries feature, which was our main focus area for this session. Let's start with text extraction. So text extraction is our OCR functionality, which provides industry-leading accuracy when it comes to extracting text from a document. Using our Detect Text API, you're able to get information in three levels of hierarchy. The pages in a document, the lines within the pages, as well as all the words within the line. And as I mentioned, this is being used by customers to extract all the information out there in a given page or in a given document. But we go way beyond text extraction with some of our higher order features. The first of these is our tables feature. This is really relevant to extract tabular information from documents that are found in industries like finance or healthcare. So if you take a typical financial statement or a medical record, you will always find information which is embedded in tabular structures. So our tables feature within our analyze document API is what we go to extract this kind of information. It is able to pull out all the tables in a page as well as the cells within a table. And on top of that, you not only get um, the actual information, but geometry information on where exactly the table is within the document, as well as a confidence score associated with the table that is extracted. The next higher order feature we have is the forms feature within our Analyze Document API. This is very useful because a lot of information that you find in documents across industries is in the form of key value pairs. So if you look at the example on the left side of this slide, name, date of birth, gender, these are all uh, they have a natural structure where there's a key like full name, and then there is the value, which is John Doe. And using this feature, you can just simply extract all the key value pairs and use them either to store them in a database or to run analytics on them or use them in your downstream process as you want, without having to go through the OCR text and try to identify them yourselves through any sort of post-processing. Great. So next is we move to our specialized APIs. The first one is our Analyze Expense API, which is useful to process and extract information from invoices and receipts. Now, this is really important and relevant for customers across industries because most customers have an accounts receivable or an accounts payable function where day in and day out they get receipts, they process receipts and they're trying to extract information from receipts. And this is actually a really tough problem because for anyone who has bought stuff, they know that receipts don't come in uh, any one consistent design or template. Um, a, a receipt from a Whole Foods will look very different from a receipt from a Target or from any other vendor. And so typical rules-based or template-based extraction of information from these type of invoices and receipts is inefficient because you're constantly trying to add new templates and update templates. Analyze Expense solves this by using the latest machine learning capabilities to extract information from this. The output that you get is a series of fields which are normalized fields. This is the most critical information that you're going to get from the receipt, like the vendor name, the net sales, the total amount, the taxes paid, etc. On top of that, you also get the individual line items as part of this receipt. So just looking at what you see on the slide in front of you, for this Whole Foods receipt, there were the item was the pizza slice and the price that was paid was $3.5. So it's able to extract these line items as well on top of the key summary fields. Now, the benefits is that, like I said, you don't need to worry about any templates or any configuration required. You do not require any ML experience or ML skills to use this. You are able to get detailed information from this invoice. And one of the additional less talked about benefits is that these fields, the summary fields, are what we call normalized fields. So irrespective of how it is labeled on the actual image, you will the output would come in the form of these normalized fields. So you are able to actually store all the information across different invoices and receipts and run analytics or trends on top of them as you need. Moving on to the next specialized API, which is identity documents. This is this is also a similar challenge to our invoices and receipts use case, where, as you know, ID documents vary in design and structure by state, by country, as well as even by age, for that matter. So if you try to use a simple rules-based or template-based methodology to extract information, you will constantly have to update your templates and maintain post-processing code on top of that. You no longer need to do that with Analyze ID, which is our specialized API for ID documents, which automatically extracts all the important information from US driver's licenses as well as passports and provides that to you with extremely high accuracy. So the benefits are similar here. You don't need any templates or configuration. You require no prior machine learning skills to start using this. you're able to get over 95% accuracy for all US driver's licenses and passports out of the box. And similar to analyze expense, you get output. The output is normalized fields and names. So you're able to get and process ID documents from different states and different countries and normalize and store all of this information in a database that you can use later for your purposes. Awesome. So now we come to the meat of the discussion today, which is the new Textract Queries feature, which is our latest release, which came out in April. And Textract Queries, like I mentioned, is a feature that provides customers the flexibility and accuracy they need to extract exactly the information they want and when they need it. Let's, before we dive into how Textract Queries works and show some examples in action, I wanted to talk a bit about the data extraction challenges that Textract Queries actually addresses. So typically, customers, despite using OCR or some of our other features, they land into 2 or 3 data extraction challenges. The first one is data variation. So if you look at any of your financial documents, you will find that the same field of information is labeled differently based on the vendor or the document itself. So for example, your social security number would be either called social security number or SSN or tax ID, depending on the document that you're actually using. So what you have to do as a customer is you need to maintain typically a synonym library, and you need to map against the synonym library and ensure that you realize that they are the same piece of information. So you're building post-processing on top of it, which is expensive and time consuming to be able to actually recognize it's the same piece of information and use it. The second challenge is that with different document versions and templates and formats, the structure of the data within the document changes. So what I mean by that is if you're trying to extract a given field, like let's say the total salary, sometimes it's embedded within a table. Sometimes it's a key value pair that's outside the table. And in some other documents, it might not even be labeled. So to be able to automatically extract this, you need to not only extract the text, but also recognize where or what type of structure that piece of information is in and write post-processing to extract it from that. This is often requires custom models or post-processing code or even manual review of the extracted data. And that is really difficult. And the third challenge customers typically find is that there are identically labeled fields in different sections of the document. A good example would be if you ever fill a loan application, there is borrower social security number as well as a co-borrower social security number. The fields would be labeled identically as social security number, but they would be within 2 different sections. And to be able to figure out whether the number that you've extracted belongs to the borrower or the co-borrower, you would have to build some sort of custom logic on top of the extracted data based on probably the geometry or the location of the field. And this, like I said, it depends on the particular template. It could vary between templates, and it basically involves a lot of additional development and management overhead for our customers. We looked at all of these challenges and we felt it should not be this difficult to extract exactly the information we want. And that's where the idea of queries came from. We wanted to make it really simple where our customers could just ask us for the 5 or 10 things that they want from a document, and we do the work and give them the exact data that they want with high accuracy. And this is where queries comes in. So with Textract Queries, you now have now have the ability to not only send in the document, but also specify the exact information that you want. So in a given document, you could ask queries: what's the patient's first name? What's the first dose? When was the first dose of the vaccine administered? Or what are the YTD earnings of this pay stub? And queries does it all for you. It automatically extracts exactly the information you want and gives you the output in a question answer format based on the exact questions that you've asked. So what it is doing behind the scenes, it's combining visual, spatial, and textual cues to provide the information you need with extremely high accuracy. This simple Q&A response structure is highly intuitive and reduces the need for any post-processing. You don't need to write code to go through your OCR output to find out the information you need. The exact answer that you need is already provided in a Q&A format, so you can start using it in your downstream systems directly. And most importantly, it's the queries feature is built in or integrated with our existing Textract Analyze document API, which you are all familiar with. So you don't, it reduces any integration costs that you might need. And finally, like most of our features, it requires no custom templates or custom model training or any synonym lists of any format. Uh, Queries is out of the box, pre-trained, ready to use so that you can get started as quickly as you want. Let's see a few examples of this. So what you see on your screen here is a typical pay stub that all of us get every month. And a pay stub is typically a very complex structure with information within tables or unlabeled information, which has your name and your address and stuff like that. So now, if you wanted to extract specific pieces of information using queries from this document, you could just ask free text or natural language questions. Like you could ask, what is the gross pay for this period? And Queries is able to automatically go and identify the right piece of information within the table. This is really powerful because the alternate to this would be you parsing through all the OCR text and trying to identify which text maps to the right column and row and being able to extract that. You don't need to do any of that going forward. Queries does that for you. You can even ask, what is the company name? Here, there is no explicitly labeled field which says that any company corp is the company, but Queries has been trained on a multitude of documents and it automatically recognizes that the field on the top left, which is highlighted, is the company name and it's able to grasp that for you. Let's look at another example. Now, if you remember the data challenge I described around nested data or section data, this is exactly the piece over here. This is a snippet of a uniform residential loan application, also known as a Form 1003. And there are two sections within it, which is the borrower section and the co-borrower section. And within these sections, there are two identically labeled pieces of information called date of birth. Now, let's say you're only interested in the borrower's information and you want to know the borrower's date of birth. You can just say what's the borrower's date of birth and it's automatically able to pick that out and give you an answer 1/1/1900, which is the borrower's date of birth. There are two things happening over here. One, it's able to automatically hone in on the right field within the right section and give you that information. Secondly, date of birth, if you see, is not actually labeled as date of birth, it's labeled as DOB. And Queries is actually able to automatically recognize that DOB is the same as date of birth and give you that answer. This, like I said, reduces the need for you to maintain synonym lists of typical fields and syntax lists that you would have otherwise needed with OCR tools. Let's look at one more example over here. This is a typical health insurance card that you would have. And it's a really interesting example because there's a lot of information here which is not really labeled. So if you look at the information at the top of this card and the bottom, the insurance provider is any insurance company, and the plan type is any plan X EPO. Now, I know this because I have seen multiple examples of health insurance cards in the past, but it's not explicitly labeled that these are plan types or insurance providers. So most OCR technology will not be able to automatically tell you this. You would have to actually just take the text and then write some sort of custom logic that on this template, the information found on the top and the bottom are actually plan types and insurance providers. And that could change depending on a different template. But Queries is automatically able to do that. It has seen It has been trained on multiple examples of these kind of documents, and it's automatically able to extract even non-labeled or implied fields like the plan type and insurance providers and map that to the right question, give that to you directly, which is really powerful when you want to extract information. Awesome. Now that I've given you an introduction of what queries is, the challenges it addresses, as well as shown you a few examples, I'm going to transition over to my colleague, Martin, who's going to do a live demo using queries as well as Textract's other features. Over to you, Martin.
Thank you, Nav. Let me first show you how to test Textract. For that, you go into the AWS Web Console and search for Textract or pick it up from the services. And you can use try Textract and then test Textract with documents with up to 10 pages. Textract supports up to 3,000 pages, but the demo is limited to those. So we have the forms on the vaccination card and the tables, the features that we talked about before. And you can see that the tables did identify the table, but there's a sticker on the vaccination card, which kind of throws up the format. So if you want to extract the information from there, it's going to be a little hard because the data is mixed. When you go to queries, however, you can see when we just ask the question for the information that we want, like what's the lot number of the first dose or who's the manufacturer on the second dose, it picks it up correct. And here we got a couple of sample questions that you can try. You can also try other questions. If you need the date of the second dose, even though in the table structure, it's not under date, you can see that Textract Queries is able to find the correct date, even though it's at the wrong location. Let's try that with something else as well. And obviously, this makes it much easier. Let's go for the lot number of the second dose, which is also off from the table structure. But here we can find it. Oh, that's actually there, yeah. You can see that this is much easier than parsing the table and trying to find the correct information just using the tables feature. The date for the second dose, for the first dose is identified correct. That would have been correct in the table structure as well. But you can see, even though it was off, we got both dates correct. Let's go to a different sample, the pay stubs that Nav also mentioned. Let's see what that looks like when you actually try it out. So here we see the OCR, once again, the forms, tables, and we can see many tables were identified. But as Nav mentioned, when you want to extract, let's say, the gross pay from this table, and we can see that when we scroll down, yeah, you can see it even identified that this being a merged cell found the gross pay there. But in order to extract the information about, let's say, year to date, you need to parse the table, which is a little effort. But when we use queries and we just ask her what is the year-to-date gross pay, we get the correct information. And as you can also see, there's an alias underneath that. That is kind of a reference that makes it easy for you to map it to some internal canonical key or label that you have. These are some sample questions that we have, but we can also just ask additional questions. For example, what's a social security number on this one? So you're free to ask essentially any question against the document. Here you can see there's none of the sample questions, but we are able to find the information easily. And here I would like to show you when you want to more easily associate the question with, let's say, an internal key that you use, you can just add that as an alias. And this way, in the response, you will get the alias. And then it's easy to map this information to your internal data structure. Okay, let's pick another document, the loan application. And this is the sample that I've also mentioned, where you see lots of keys identified in the forms model. So you can see essentially everything in this document is a key. So you have a long list. In the console, you can click on one, and then it will highlight the key. Like the conventional, it's selected, not selected. So that's part of the checkbox model. So we can identify if like a certain checkbox is selected or not. And you can see the interest rate is in here. Lots of interesting and important keys. Long list of keys. Yeah, it's a really long list. So what I would like to show you is that here we do have the borrower and co-borrower sections. And each of those sections contain essentially the same keys. For example, the social security number is named exactly the same. The only difference when you look at the keys, here's the social security number key, and 2 above is actually the social security number for the borrower. So when you just look at the keys returned from the forms model, it's not easy to identify like which one is which one is the social security number, which for co-borrower, and which one is for borrower. The same is true for just the name. Here it's a little easier, but you can see that we find those. In order to identify what the social security number is for the borrower, we can just ask the question, what is the borrower's SSN? And once again here, I'm not using the exact key name, social security number. I just use SSN. And Queries is able to identify that I want to ask for the social security number, even though it's not the same key name. So it's quote unquote smart in that way. You can see when I ask for borrower's social security number and co-borrower's social security number, it's able to find the correct one. And this is based on like spatial information, like layout, geometry, and textual context for this question. This obviously makes it much easier to parse the document. We can also ask not only for like text, we can also ask for if a checkbox is selected, or ask for context if a checkbox is selected. In this one, I am trying to find out if conventional is selected, and I get the correct answer. Yes, it is selected in this one. And therefore, this makes it also easier to just parse the information, so you don't have to search for all the select boxes. The same for VA, just a negative test, so this should return no. Yep, and that's the correct answer, it's not selected. And we can also be more specific, and we can just ask what's the purpose of the loan. And when you look at this one, the purpose of the loan is purchase. So I don't have to parse through all the checkboxes. And this will just give me the information what the purpose of the loan is. So it's for purchase and not for refinance. Once again, makes it so much easier to get to the information that you want from this document. Okay. In the console, you can also just pick a document that is not one of the sample documents by clicking on Choose Document, and then you just select the document. In this case, I want to look at the mortgage note, which is a document type that is rich text. And we are interested in information that is within the text. Before you can actually do that, you have to select that you want to try out queries, and you can add then the queries that you would like to ask. In this case, we are interested in what the principal amount is that the borrower has to pay. We'll just add the queries here. And the initial monthly payment. and the beginning date of payment. And yeah, yearly interest rate. Let's go for that. And maturity date. So this is an example to show that Queries is able to extract information even from rich text. So the principal amount, that's at the top. And the initial monthly payment is down there. Beginning date of payment, April 2022. Interest rate 4.15, and maturity date is April 2032. Okay, let's run this and see if we get the correct answers. Together with queries, you also get the raw text, so the OCR result. And here are the query results. And queries did identify the 500,000 and the 2,500, the beginning date of payment, which is very interesting because there are multiple dates in this document, but queries was able to easily identify which date we are interested in. So the maturity date and the beginning date, both dates look very similar, but using contextual information, spatial information, we're able to get that. This year I did attend Remars, so I did a quick test on using my badge from Remars to just check for some questions where you don't have an identifier what this is. So I wanted to know whose badge this is and what company they work for and if they are an employee. And running this, once again, this is without any training. So I just took my badge, just check queries, and I got the correct answer. So that's my name. I work for AWS, and I'm an employee. Yes. So that's quite impressive because there's no key that basically says that. Okay. Using the console is a great way to test with like single documents, maybe a couple of documents, but if you want to test Textract at scale, we do have some tools that you can use, and links will be at the end of the presentation. This one, you just deploy, and it creates a full flow using step functions. And this allows you to process documents at scale, hundreds, thousands, tens of thousands or more. This is the flow, one of the sample flows. There are some simpler sample flows as well, where just process documents using queries. This one starts with one component that basically checks if this is a document that we can process. Then it enriches it with like number of pages. Then we call Textract, and we generate the text. So we have async and sync in there. Based on that text, we run a classifier using comprehend. And then we route the document, because now we know if this is a W-2 or a pay stub or like something else. And when we know that it's a pay stub, we can ask specific questions about the pay stub that we want to process, or the W-2, or whatever document format it is. We call Textract again with the specific questions. And this is just to show that we can do sync and async. Based on the response, we generate a CSV, and we send it to a relational database in the backend. We do have a couple of other states as well. So if it's like a document type that we have no idea what it is, or then we send it, or we know that what it is, but we just want to index it in a search, we can do that as well. Yeah. And all this is deployed just using the CDK. As you can see here, took like 6 minutes to deploy. And you can do the same. so instructions at the end of the presentation. When we upload a document to an S3 bucket, like in this case, it's just call it blah because it's like nonsensical repetition of the word blah. When I upload this to an S3 bucket with a specific prefix, so here you see what the document looks like. It's just blah, blah, blah. So you can't do much there. Queries cannot deduct anything from this that is useful, I guess. It's just to show like what the process will do. So when we upload it, it will kick off this workflow. And you can see that it passed already the initial check. So it's a document that is supported. Textract did run OCR against it. We did the classification. And the classification did yield that it's a document type where we don't know actually what this is. And the classification document type result was none, which makes sense. Like with this kind of document, we don't want to run any expensive tests or like even submit it to a human in the loop at this point. The other document type that we will test is this, which is I trained the classifier to say this is like an other document. And this one will be submitted to an open search index. There's no information in there that we want to extract, but we still want to be able to search for it potentially. And this obviously is just a sample. You can see here the status is running. Textract does the asynchronous processing in this case. Done with that, generate the text, we do classification, and you can see that the classification did yield the document type to be AWS Other. That's like an internal one that I created, the classification. And we just send it to an open search index in that case. Cool. But now let's look at some information that we want to extract. Part of this is a relational database. So here I use a Postgres database, and you can see it's empty right now. The table is empty. Now, when I upload a pay stub to this process, and the pay stubs look like this, and we are interested in a couple of information, but let's say, so we want to check later for the gross pay. So it's $770 and the year-to-date pay, gross pay. Let's check for those later. So we upload the pay stub, and this will kick off another process. And this time, so we do Textract does do OCR, and then the classification should this time identify it as a pay stub. Let's check. I mean, you can see in the process it already did that, but here's the AWS pay stub. And now that it did that, we know that we can ask these kind of questions, like what is the pay period start date? What is the pay period end date? Or what is the current gross pay? What is the year-to-date gross pay? By asking these questions, we will get the answers. We will generate CSVs based on the answers, and in the end, submit it to the Aurora database that I looked at earlier. So let's look at the database again. And we can see the information is populated. We can see that the current gross pay is $770 and year-to-date gross pay $2,310. And we get some additional information as well. So just by submitting this, we got a new relational database in a structured format. And now we can start using that information for decision making. Let's do the same with a W-2. This is what the W-2 looks like. You can see that information. And here, let's look at this process, W-2. And Textract does OCR first, because we need to identify that this is actually a W-2. And after this process finishes, then we do the classification. Yeah, classification already done. And it's a W2. And we can also see that we send different questions to Textract for the W2 than we do for the pay stub. Now we're asking what's the employee SSN, and we send it to the database in the end. So that's all parts of the process. When we check the database, we can see lots of information there. For the W2, I actually do submit all the form information as well. So at the top, the values you see at the top are from forms. And we also get the questions. Now, this process can also be used at scale. So now let's submit, I think this is roughly 200 or 240 documents into the bucket. And when we look at the process itself, we can see that there are many executions in running state. So now it's doing its thing. Textract is called. We do classification on those, extracted, submitted to the database. When we look at the succeeded ones, these are already finished. And when we look at the database, we will see that there's not only the initial pay stub and W2. Now we see additional pay stubs that were processed, additional W2s that were processed. Much more information flows into the system now. And by the way, so initially, when you start using Textract, there are limits similar to EC2 limits or other limits that you're familiar with on AWS, how many concurrent processes you can run or jobs you can run. So with Textract, you can also increase those limits in order to process more documents concurrently. So here we see we're now at 3,500 data points extracted and continues to extract. So it looks like almost all of them are done now. Succeeded. Let's check. Oh, there's one still running, but we can also filter for that. Looks like that one finished as well. Now all the processes are done. And we got 5,880 data points extracted from all those documents within like 1 minute or so. Cool. Thank you. Up to you, Nav.
Okay, great. So we want to leave you with some resources that can get you quickly started. As Martin mentioned, the code samples on GitHub are there on this slide, but on top of that, there are links to some blogs that walk you through step by step how to get started and utilize not only queries, but also some of the other features of Amazon Textract in practice. Yeah, so hopefully these are helpful for you and can get you quickly started. Thank you so much for joining us today. Hope you enjoyed the session and looking forward to any questions.